All right. Let's get this stream going. The focus of the day is playing around with extruding curves to make surfaces. I think that's pretty much where I'm gonna put my focus. And I'm gonna do it in this namespace where I can kind of work on these kinds of surfaces here. I feel like that's pretty cool. I feel like that's a pretty good way to kind of use my time. There's one thing I want to check in on first though, and that is what went wrong here. So I'm just compiling a different vase design, and I'm pretty sure the mesh failed in this case. So I want to see if I can find out why. Yeah, something went wrong. Whoop. I'm not totally sure why. So I'm gonna quickly try to get to the bottom of that. And then I'm gonna work on some surface stuff. I feel like that could be pretty cool. I might even come up with a pure SVG surface rendering tool to get sort of a wireframe render. That might be fun. Then I'm not like necessarily bound to using OpenSCAD, but I'm getting ahead of myself here. So this is a bit peculiar because this looks like it would work, but I'm gonna guess that there's something wrong with the top and bottom faces. If I look here, it looks like I'm missing a triangle. So let's hop to it. Okay. I'm just realizing too, so the ear clipping works for concave polygons, but leaves kind of bad meshes with these really like a ton of thin triangles. I'm just thinking in my head if there's maybe a better approach, you know? Like, I'm actually kind of wondering if I should automatically split into quadrants and then triangulate the quadrants and then stitch those back together, so at least I don't get a very one-sided result like this. But maybe I'm getting ahead of myself a bit if I'm honest. So I'll maybe deal with that later. Let's figure this out. Let's get rid of this and have a look at what that shape looks like. Let's also now do this. So it looks like at least there's no triangles incorrectly angled upward. Right. Okay. Oh, excuse me. I wonder if it's actually not this body that's the problem, but another one. Let's see. Like this. Turns out it's kind of difficult to tell. Let's do view thrown together. So they're at least oriented correctly by the looks of things. Oof, that's some really thin, bad triangles there. But for right now, that's not the problem. They're valid triangles, so that should be okay. Let's look kind of cool actually, but I digress. Let's add back in this to try and get to the bottom of this. Alright, so we got the surface, the main surface in there. I'm just not certain if there's any gaps, like, oh, I guess I could go ahead and calculate it and see if it works. Rendering finished. Okay, so that works. Let's try this one more time. Okay, so we've got the main outer shape and it renders fine. That's good. So it's a actually, sorry, I have to do another thing here. Design. So let's check validity. The given mesh is not closed. Okay, so there is something wrong. Let's get to the bottom of this. The given mesh is not closed. That is the problem I have to solve. Once that's solved, it should guarantee that things will render. Sometimes it'll render even with errors, but that's not reliable enough. So that's just not going to be good. So let's see why that would be. I'm gonna help myself out to turning this segment count down a bit as well. Maybe then I can get a little more visual help from the thrown together view, so I could maybe see where the gaps show up in that case. Let me design check validity here. It should, yeah, okay, it's also, or still not valid. I see it right here. Okay. So, I am missing one that's basically all it is. I think I'm just missing one end point. So I'm gonna go ahead and guess that okay, this I don't think will solve the problem, but I forget, but I think there's actually an important reason to not ink that. And there we go. Okay, so that actually solved the problem. And well, let me see. No, it still did not solve the problem. Oh, it is valid. What? Maybe it just didn't reload. Well, that was weird. Okay, so that solved it. I think the reason is due to how I set up the wrapping logic, where so I was going to the very end of I was going from 0 to 1 in that range, sampling all of those points, and then it was deleting one of those points. So if I instead only sampled one behind, like to 1 to the 0 to 0.99 instead of 0 to 1, then that sampling logic didn't flip on and accidentally delete a whole triangle. So I think that makes sense. Okay, well, so with that logic, let's pop back into the vase here and see if we can get this working. Let's make this an 80 sample, so we'll do a smoother surface. Okay, so that is loading. It'll take longer because the triangles are going to be much smaller again. I also have a vertex out of range problem, which I will get to, but first I would like to see if this will actually calculate the final mesh and produce a valid STL from it. It looks like it should. So one thing you have to keep in mind when you're doing OpenSCAD stuff, that the quick preview might render, but that doesn't guarantee that it's a manifold, like that it's a properly formed mesh. It does not guarantee that it will export an STL. So you have to actually run the render here. You have to calculate the full render, and if it can, then you can export an STL. If it cannot, then you can't properly export an STL. So that's why I'm doing this, just to sort of verify that my Polygon clipping approach is working. So that's a good thing. Would you look at that, eh? Let's turn off the edges. There you go. That's pretty cool. I like that. All right, I'm happy with that. All right, so Well, so we've now got a volume function that works. I am, just for fun, gonna see if I can quickly make a, let me see if I have it. Excuse me. Okay. Let me get this into the right spot here. Let's do this. Just want to make sure that I start to capture the useful bits, the useful algorithms into the right libraries here. Yeah, I'm sorry, I'm distracting myself by thinking about other stuff right now. Clearly not helpful. These functions are actually going to be useful in other things, so I should probably put them in utils. Let's do something like this. Examples dot. You know what? Let's just do there. That's probably a bit better. Okay. Test is maybe a bad. There we go. And this one isn't actually a function, or it doesn't need to be, I should say. So let's do that. This one here, I will do this, probably. That looks pretty good. That looks good. Okay. All right, let's do, well, actually, let's do it this. Let's make sure we get that lined up in here properly. We want to do examples / algorithms, HTML, algorithms, examples. Seems good. Okay. Oh, yeah, and then I have to do this. Like that. Inside point example. Run it twice. No reason. There's not. That's fine, I guess, to do it twice. It doesn't really need to happen, but RemoveCollinears example. Okay, that seems pretty good. It won't work yet because I haven't put all of these into the right namespace, of course. And what I actually need to do is make sure, oh, there's also simplify. Ooh. Right, I do need that in there. That'll be in parametric. It makes sense to do that. Inside there, p/simplify. Yeah. Oh, shift points is also going to be really important. Right, so what shift points? Yeah, okay, so those will both, it kind of makes sense in my head that they end up in parametric. Let's change the arity options of this here. And how I want to do this is actually like this. I want to shift points, start. And now here, points start like that, and then I do let. Okay, that should work. Shift a list of points. Shift a list of points. What's the right way to describe this? Shift a list of points to begin at start. Preserving order and cycling the list. What's that called? Where it's a loop. A closed list, a looped list, cycling list. Name of a list that cycles back on itself. What's that called? No. This doesn't matter. There. And cycling the list. Let's write another little, if no start is provided, the point with lowest x and y value, lowest x and y values is used there. So the left bottom or left top, depending on the orientation of the y, but that's that. So simplify points. Oh, let's also do this. Simplifies the list of points by yeah, if n is greater than count of points, how do I say it? This does not guarantee that input points are preserved in the output. So it's actually maybe simplifies a bad name. Like maybe it should actually be subdivide or something like that. Although that's technically wrong as well. Well, let's not worry about that right now. I think that's pretty good for now. All right, let's keep this ball rolling. I'm quite sure I've forgotten something now that I'm working on this, but let's see what's up anyway. So we've got I hope there's not a circular dependency problem here. That is frustrating. Well, let's see what we can do anyway. How about we figure it out? Excuse me. Okay, so this here makes sense actually, in my opinion, to put here. Okay. I mean, these realistically, it makes sense to put them in here as well, angle stuff. That makes sense to me, I think. Actually, does it? Do I need to worry about it that much? Okay. Put them in here. We do this as well. Point inside goes here. That makes some reasonable sense to me. Better than nothing. I also realized, where am I at here? This actually can be this. Little helper functions. There. So now cross product won't fail when you pass it a 2 vector. So that's probably a good thing. But anyway, we've got angle stuff. We should go here, intersection. These we should move to be like up in here. Okay, I will have to reload all of this to make sure the shuffling is all gonna be okay. Helpers, that's fine. I guess that's okay. Intersection is a line intersection. Corner tries, corners and tries, that makes sense. Point inside, that makes sense that that's there. These, math abs, although technically I can make that abs, right? Yeah. Where did it go? Here. Okay, we got abs like that. There we go. This, I should leave these in there. For now anyway, seems useful. Okay, so we got that handled. This. Remove collinears. I feel like that should... it's a little tricky because it kinda... Well, for sure these I can take out of here now, which is that's a good thing. So let's go with that. Let's do this in here. Okay, because what part of me wants to do is It's a little frustrating to figure out exactly the best way to divide things up. That's what I'm hesitating with, that's all. So like remove collinears, I feel like it could be a useful function outside of the context of the ear clipping algorithm. So I want it available, but so I would put it with the other point-based stuff in parametric, but parametric is using algorithm inside it. So I'm a little pinned, you know? I mean, I could subgroup things, like algorithms have their own tiny namespaces. That's maybe not a bad idea, but that's a little annoying as well. Okay, let's not worry about that. Let's leave this like this. We'll leave that in there for now. Yeah, that's, I'll leave that there. I might like kind of duplicate it as a tool here, but that's a little risky. Like to define, basically I would do like define remove collinears points, and it just runs alg slash remove collinears. Suppose that's fine. Okay, that solves that immediate problem. Now let's finish putting the ear clipping code into here, then load things up and go from there. And then we can fix errors. Certainly there's going to be something that I've missed. So I'll find it. Apply utils slash collinear. That should be pretty good. Okay, so everything in this chunk is handled. Now we get into here. All we need to do this kind of thing. Zoop. There we go. Utils slash corner condition. Okay. this, I shouldn't need this actually. Let's do this right for a second. Corners. Okay. Points gets run through the function concat that with take two of that. Okay, that's actually, I can run it like that. I feel like I may have to reorganize my namespaces again in the future, but for now I'm gonna just be okay with it. I'm thinking too far ahead about too many things, I think. Right, so take this. Except instead of passing corners in explicitly, it's implied that it's passed in there. Okay, this should be fine. Let me temporarily do this. Excuse me. Point inside is in utils, like this. So let me also temporarily do this. I gotta go to the bathroom for a minute, I'll be right back. All right. Just had to poke my head outside for a minute. Check something over there. Out there, I mean. It is raining once again. So let's see what's going on here. All right. All right. Okay, so I am now in the business of loading this namespace up and seeing if it's gonna work. As in, I think I got all the right functions moved into the right spots, but I'm sure I missed something, and I'll just test that quickly. Oh, I also probably should do something like this. Oops. Your clip example is going to be let's actually do this. Call it a draw instead. That makes sense to me. Oop. Didn't mean to do that, but that's okay. Okay, that looks good. Draw triangulation. You know what? Let's keep it close to where it's used. Right here. Yeah. There we go. Yeah. Okay, let's save this. Now, let's pop that into the REPL and see what fails, because I think I have to reload everything. Well, let's do this. MX sman restart. Let's give that a shot. Do 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 do. Okay, let's see what happens now. Okay, that is not surprising. Let me do myself a favor and declutter the screen a little bit. All right, so we're working in the SVG area here, and let's go with that. So we've got the algorithms example down here, but I want to fix this problem in the Here we go, utils / corner condition. Let's try that again. Load file, source, svg, clj, algorithms.cljc. Okay, that seems to have worked. No such namespace p. Okay, yeah. Not surprising. So like I said, I think everything's fine. It's just a matter of having messed up some simple things, you know? Like forgetting to make this just say Polygon, for example. And now this becomes, well, let's load it again. Parametric, not algorithms. Ah. Let's Bezier, blend, stroke points. Okay, here we go. So we can do it like this. Points utils will be fine if I pop it down here. That should work. A little annoying, but I feel like that, excuse me, that could be okay. Let's try that. Okay, there we go. Now let's see. Okay, it looks like we're heading down the right path here. Let's try to eval this whole thing and see what breaks. Okay. Something unbound, okay. There we go. That makes sense. So we've got to find this and do utils /. Okay. That's unexpected. Okay, let's go one chunk at a time here. Where did I go wrong? Not what I meant. There we go. Okay, well, let's try to get to this, get to the bottom of this. Okay, so that works. Let's do RemoveCollinears example. That works. Okay, ear clip example seems like it might fail. Okay. Why would that be? Concave, draw triangulation. Okay. Ah. Oh, I didn't actually run the triangulation. That's why. Alg slash clip ears concave. Okay, here we go. So now we're into some substantive issues, and we can fix those. Okay. Illegal argument. Okay, so I messed something up inside clip one ear. So that it's annoying, but that's okay. We can work with that. Let's pop back into the algorithms then. Clip one ear. From, let's do, okay, good. So this here, clip one ear, don't know how to blah, blah, blah. That I can fix. That I can do. Okay, I think it might actually, this might have to go like this. That might fix that. No. Well, let me sanity check myself here. Is this gonna, right, any convex, I need that here. Huh? Okay, let's try this again. Okay, so that does work. It's just that, okay. Oh, I think this is what I did wrong. I have to do this. So I first have to do this. Okay, is this going to be readable? That's the thing I'm not certain about. Let's see if this works though. No. Right, well, let's pop this back. Let's try that. Okay, there we go. So what I just did there is fixed up. I had, from the original implementation, a check for the winding order, and I would switch it mid-triangulation, which it was an attempt to fix another bug, and it was never the right solution, so I don't need that anymore. So I'm just cleaning up this function a little bit. So if I do that, that should be better, hopefully. Okay. Let's go with that. Let's switch back now to this here. All right, that looks like it actually exported something. So let's now go here for a minute and do file. Cypress isn't what I need, but let's do. Okay. Algorithms. I mean, that's kind of atrocious. You can't really see anything. So let me fix the styling, because it's a style problem, that's all. Right, so fill black. Let's make this 3 and then this 1.5. Actually, let's do this 2.5. Okay. Oh yeah, I should also do this. Stroke black. Try this again. There we go. Oh, excuse me, I've got itchiness in my eye there. There we go. All right, there we go. Now things are coming together, I'd say. I feel like a better example for this might be to do the fillets, although I'm not too worried about that. I like this. This is good. This is good. Okay, there we go. We've got a pretty good scenario going with the SVG library now. Let's do hello. There we go. Let's do CLJ-M test. Excuse me. Okay. Let's see. Get list tags. Get tag. Oh. I feel like I'm not perfectly. I think I am not using tags totally properly, if I'm honest. But I guess oh well. Get tag 0.0.8. Get wait, what did I do? Yeah. Get commit m. CLJM release. Hopefully that release works. It should. .08. Uh-oh. Oh, what did I do? I messed something up. Okay, I have to, might write a little note to myself here. Here, 0, git commit and push latest changes. Then you do all this stuff. Okay. Okay, let's go with that. Let's do assessment quit. Kill that. All right, here we are back in the pottery namespace. Let's see, hopefully, that this works. So if I do here, if I go here and do mx sesman restart with the new depths saved on this, which, okay, good, I did save it. It should hopefully work. I guess we'll find out. Okay, seems to have worked so far. Let's do this. Yes, 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 I know that. Okay, utils, shift points I shouldn't technically need anymore because that actually should exist in my SVG library now. Okay, so I should be able to do this. This should work. Okay, now we're good. Triangulation should also not need to be here. I should be able to do this. alg/clip ears. That should work. Try indices. Oh yeah, I do need to eval that, of course. Okay, seems promising. Let's see. Shoot. Something went wrong. Simplify, yes. That's going to be parametric / simplify now. Yes. Okay. Now we're good. Now we're cooking. Show edges. Look at that. Fantastic. Okay, it's going to be a really low res. Well, res is kind of the wrong word, but a low density. There we go. Should still work. Yes, all right. Love it. Oh man, I'm pretty pumped about this. This is pretty cool. Okay, so, right. I kind of now want to, well, first of all, let me do this. We've got show 2D utility, that's helpful. The triangulation stuff, I don't really need any of that. But I will put this show triangulation up here in the show 2D, like in the helper utils area. That makes sense to me. This triangulation algorithm, I can actually just delete this whole section. I don't need it because it's taken care of in my main SVG library now. Boom, new feature. Love it. Okay. Let's also, excuse me, have a look at how do I want to handle this? Well, let's see. I actually am curious about if I do, let me see this. I have no idea if this is gonna, let's try to extrude a surface. Let's so surface, do that, length and width. Okay, so we've got let sorry, I want to do width and height maybe. So we go in here and we do half width, width half, height half, map, divide by 2 over width and height, So now we've got the half width, half height. Let's do, so a surface is going to be a function that takes uv and returns a coordinate. So in this case, the rectangle, everything is going to be a surface initialized on the xy plane. So z is 0 in this case. I'm going to get into, surfaces are going to be more general, but this is a good testing surface, right? I think anyway, that makes sense. And we're just going to do surface like that as a function. It's basically gonna just be, well, let's start with super simple stuff and build a more robust solution from there. So the wraps, we actually won't need to wrap indices, which will fix all that up later. I have this open surface thing here, which might actually be good enough for what I need. Actually, maybe I should try that. Yeah, let's get rid of this, and we'll do open surface as the testing. We'll do this. So what I'm trying to do now is just build a surface and see if I can just run an extrude and if OpenSCAD will do that automatically, or if I have to kind of convert it on my own into something different, in which case I have to do the surface extrusion totally Clojure side and just emit a polyhedron from that, which is fine. I think I kind of want to do that way anyway. That way I can generalize it beyond OpenSCAD and just build my own viewers and stuff like that, and start to build in some kind of tool for handling it as if it were like a brep, so that I can make like proper step files with it. That might be a lot harder than I'm thinking, but I'll cross that bridge when I get there. In the meantime, I'm gonna just build stuff that is useful and kind of go from there. Okay, so we've got open surface, surface, seg, like that. Let's do that. Okay. Right, so a rectangle surface is actually, I can define it as two lines sharing one corner and going up in U and then up in V like that. So let's let U line be P/line from, the starting position is going to be negative width half, negative height half, bottom left, to width half, negative height half. That's that line. And then the V line is starting at this same corner and going up to, it's going to stay at negative width and go up to positive height. So those are the lines. So then in here, all I have to return is wait, let me make sure I'm doing this properly in my brain. So I need a 3D position from this. So in this case, I know Z's going to be 0, so that's easy. So let's just think about what I'm getting. I need the X coordinate from U and the y coordinate from the v line. Oh, this is that correct? I think that's right. I mean, we'll find out quick enough, right? Let's just build it and see what happens. Okay, so the function that returns from this is just going to return a 3D point. So we can actually just do it like this. We can do let's do first from u line at u, then second at v line v, and then 0. Okay, let's see if this does what I want it to. I guess we'll find out, huh? Okay, now let's do let's get this. Whoops. Instead of a vase, what I want to do is def surface rect surface, like that. It's just going to be open surface of rectangle 100 by 200. Okay, but I have to define this, right? Then define this. I think I may have done that already, but that's fine. Ooh, what did I do? Oh, right, I need to do 20. Let's see if this produces a result that makes sense. It might not. Okay, well there's a surface. Promising. Let's do view thrown together. What is all this? I need to show these edges. Something's wrong here. I think I've accidentally produced double the tries. Let me sanity check that it's actually having an effect. Okay, so there's something wrong here. I've doubled things up. But I'll sort through that when I get an opportunity. I think I'm accidentally still wrapping things around. I think that's what's going on here. Because I think I've accidentally overlaid two triangles that like go from the one side of it, wrap it all the way around to the other side. So I think that's the problem here. Oh, or I might accidentally be stacking things incorrectly. Let me see. I have to figure this out. We'll get there. I mean, it's clearly got the correct basic shape, like it's a square, so that's helpful. But the question will be, does it extrude? If I have a properly formatted surface, does it extrude automatically in OpenSCAD? I don't think so, but I do want to find out. Okay. don't know if this is right, but let's just go with that. VSeg for now. Let's give that a try. It's the first thing I can think to change, and that didn't quite do it. We've still got the triangles wrapping over, and I think, ooh, that's okay. This looks to me like an off by one error, which is annoying. That's okay, it's solvable. I'll be right back though. Okay, let's sort this out. We got to get this working. It's just well, actually, let's try. I don't think this is right either, but let's be lazy and do the dumb thing first. Do the dumb thing and then do the smart thing later. I mean, that looks cool, but it is still the same problem. Okay, so what's happening? Ooh, that looks way wrong. I like it. Okay. So if I do this, I do at least get, oh, let me, okay. I get all of the correct triangles. The only thing is I get just one row of incorrect triangles looping back on itself. That's what's happening at the end here. Okay, so I have UVs is a regular grid. It's theoretically fine. The try function is an index and then it returns adjusted values. Then the tries, you map cat try function. Drop last seg here just clears the last, like the whole top row of UVs. But what I actually need to do is for the UVs, I need to drop the well, I could do like if the index is mod I could do something kind of like, I think I might have done it here. One second, what's correct here? Right, it's here. If and not and the mod of, I don't know why it into, oh, it's that I can do that. Okay. This comparison I can use. I think this will get me the right result. Okay. Right, so if that's true, then you give it that. Otherwise, oh, I could just make it a when, then filter nil. That's what I'll do instead. Okay. Right. Hopefully I'm thinking about this correctly. Right, so what I want to do is mapcat that, remove nil from that. Okay, let's see if that does something for me. Huh. Wrong. Very cool, very wrong. Okay, love it. I wonder what this looks like. Oops. Nope. There we go. Here's what I'm wondering. Yeah, that doesn't do anything. No top level geometry. Okay, well that kind of solves or answers my question anyway. Okay, let's do let's just double check this in the docs. How to generate extruded 3D model from images? No. No. What? Open SCAD extrude. This is totally unrelated. I am now just curious. Oh, that's very cool. Oh, that's very cool. I love that. I like that. Okay, that's not relevant to what I'm trying to do. Open SCAD website. Let's go to it. Org. Okay, let's go documentation. Oh, file paths, I see. Oh my goodness, the screen is blowing my face up. Oops. There we go. Okay, I understand what extrusion is. A 2D object as input generates a 3D object. Okay. Yeah, okay. Oops. Okay. Okay. Well, let's get back to this. Let's not extrude it then, because it's clearly not the way to do it. Okay, let's try to fix. What? What did I do? There we go. All right. Okay. Hmm. I'm not really thinking very hard right now, to be completely honest. And that's not a good way to solve problems. So we're not gonna get anywhere just by fiddling around like this. I really should hunker down and think about it properly, which is probably what I'm about to do. Even though I'm tired and lazy today, to be completely blunt about it. But that's alright, we'll get there. You know what I'm gonna do, just for the sake of trying it out? I'm gonna do this. Still not correct. Ooh. Something went wrong. Arity exception. Surf. Oh yeah. Right. So that's the wrong. Here. It's like this. There we go. Okay, good. We at least have something showing again. We're back to, I mean, obviously not working, but let's just invert this and see what it looks like. It's wrong, but it's getting there. No, it's not. It's just wrong. There we go. Okay, I think we're good now. Yeah, okay, good. Ink, index, ink that, boosh. So I think I had to increment the segment here because I'm not doing a wrap, which I don't remember. I have to go over it in my head again and write down what I've done. Got things running out of battery here. Gotta find the right charging cables. Ay, ay, ay. There we go. Okay, so if I extrude a surface, there's kind of two things that should happen. One, it should generate the surface, like the sides of the surface, and it should generate the caps on either end. let's do something like this. Extrude surface, surface H. Okay. So I need a way to find the surface's curve, actually. Because then actually what I can do is just have an extrude curve function, and then extrude surface just uses the extrude curve function, and the extrude curve is gonna just be the logic of the volume. This should actually be curve, not even surface. No, this is different. This is not extruding. I'm confusing myself a little bit. Okay. Let's act. Okay, here we go. So now we've got a simple extrude function. Curve extrusions. Okay, here we go. We've got a blend extrude function. Now let's make just a curve extrude curve or whatever. Curve Z. It's just going to be a single curve, just going to be a single Z. Even easier. Okay, this should be super simple. Right, so you take the curve, all you do is concatenate the results curve I don't even, it's actually just this. It's just concat curve U Does that work? Let's see. Okay, let's do def A P circle 100. Okay, so A at 0 is some value. A at 0.5 is some value. Ooh, let's do 0.35. There we go. Okay, so now let's do def B is extrude curve A by 100. Okay, so B needs to take 2 points. Okay, that looks promising. Well, so now we've got extrude curve. Let's def of test surface here. Let's just do this, circle 200, volume, extrude curve. And then the curve is just B, like this. Let's try that. And let's spit pottery.scad scad/right. Is that gonna work? Okay, so that does work. Okay. Excuse me. Alright, so what I need is to find a way to do the boundary curve of a given surface. So that is going to be the points. It's going to be let's see if there's a clever way to come up with the boundary given a surface. The parametric surface function will be a function of u and v. All I need to do is see, the potential issue is you can have a surface where u and v so I'm having a hard time thinking about calculating how many hard edges a surface might have. So a surface can have UV coordinates but still only have a single bounding curve. So that's an ellipse or a circle, for example. It can still have UVs but have only a single continuous curve bounding it. It can have 3 edges like a triangle and still have a UV coordinate system. It can have 4, so like a quad situation. Or it could have, can it have like more than that? Or else it would be just like a combination of triangles or something. This is maybe currently beyond my capabilities. Oh, hey, Viva. Thanks for the raid. And Oga's Halit, sorry if I get your name wrong. I'm not always great at pronouncing things. Thanks for the follow. I really appreciate that. I think my little notifications didn't pop up on the stream. Sorry about that. How's everyone doing? I hope everyone's doing okay. Let me turn off the thrown together. There we go. Let's extrude this just to make sure this is working. Hey, how's it going? Seems like a missing texture error. There's no error going on. What this is I mean, granted, I get why it would look like that. So what I've done here is I'm working on some functions that generate the triangle mesh, and then it's going into a program called OpenSCAD here, and it's just, oh, just a joke. Oh, sorry. I'm sorry. I'm in a serious mindset, and I missed that went over my head. Sorry about that. How's everybody doing, by the way? I hope things are going well. I do use that, though. It is good to have this in here. There's a view in OpenSCAD called Thrown Together, and if you turn on edges, it's all pink and stuff, but it'll show you the back face. So like back faces will be pink, and that helps you quickly detect winding order errors in your generation. So that is useful to have. Yeah, it's like a debug color, and this, it's just because I haven't like the segment count in the U direction is equal to the segment count in the V direction, when for certain extrusions it's totally a waste of it's a complete waste to do that. Like these really thin triangles along a vertical like that should be optimized, but I haven't done any of that. So that's why at a distance it just looks like this pink blob, which you're totally right. Krios, it does absolutely look like a texture error. I do like it just by happenstance looks cool, I think, to have. So this circle is triangulated with a very simple ear clipping algorithm. My brain just exploded with Viva Lambda. It's too much math. What was Viva working on? Some math heavy stuff on their stream? I mean, parametric curves and parametric surfaces are arguably math related. I mean, obviously they're geometry, but I've not been working too intelligently today. I've been a little bit distracted, to be totally honest. So hopefully your brain doesn't explode if you're tuned into my stream. But yeah, so this unrelated to any of that. This just looks kind of cool. This is triangulated with a ear clipping algorithm, which works on concave polygons, which is why I'm using it. It's also fairly quick. The problem is it does generate bad meshes, as in there's really thin triangles, which is usually not a desirable thing. So I'm gonna eventually have better triangulating algorithms there, but for purposes of getting something working, it worked pretty well. And to give a little bit of context for anyone just tuned in, oh hey, BixieV or Bixieve, sorry if I get your name wrong. Welcome. I hope you're doing well. It says you're a first-time chatter. It's nice to see that. What brings you to the stream? Were you watching Viva's stream before? You just got dropped in here. Ooh, unable to resolve symbol simplify. Well, I can fix that. Krios, it worked. Dropped with the raid. Oh, nice. Well, welcome. So for a bit of context, if there's anyone totally new, I use Clojure to do 2D and 3D CAD programming. This is I think a fairly well-known CAD tool called OpenSCAD, and there's a Clojure library that compiles a Clojure program into OpenSCAD, so you can use it to generate 3D models. What I'm doing is making parametric surfaces by extruding parametric curves, which I can use which come from my 2D SVG library. So for example, if I do tools, cider, show, actually, sorry, let me do this. Show 2D. Krios, they were working on deep learning algorithms with Python and NumPy. Oh yeah, that'll be math heavy for sure. A lot of probably a lot of matrix multiplications and whatnot, and all kinds of cool stuff like that, I would guess, without knowing anything about what Viva's working on. Just if Viva's still tuned in, thanks for the raid, by the way. Hopefully they heard that, or at least they know that the world knows that I'm thankful for the raid. Appreciate it. Oh shoot. SCAD works on Python? It's a good question. So I'm using Clojure. I'm not using Python. But SCAD. Oh. Maybe I misunderstood your question. SCAD, OpenSCAD, uses its own language. It's its own custom language. I think there are probably bindings or libraries that someone's made in Python to export to SCAD. But if you just use the OpenSCAD tool on its own, it has its own syntax and everything. I personally don't like its syntax. I'm much happier using Clojure to emit SCAD code. Okay, here, this is what I was trying to show just a second ago. I have an SVG library that I wrote /m writing, and I can use it to make 2D shapes of all descriptions. So what I can do is kind of cool stuff like this. Let's do p/function offset, the function, and then the offset function is going to be p sine wave 2020. So there we go, right? Like I can, so what I just did here was around the curve of that circle, I mapped a sine wave function with an amplitude and frequency. How'd you learn Clojure, polygons, only docs, or other stuff? This subject is really weird and beautiful. How did I learn it? Well, I guess kind of on my own with documents, that sort of thing. So first of all, let me, here's OpenSCAD, and here's some of the stuff that, like, this is some of the example syntax and stuff that's generated natively. If I go to GitHub, here is the, I learned about some of the Clojure stuff for 3D modeling by looking through the source code of this library, forelm/scad-clj. I went in here and looked at the model and figured out what was going on. It just took a while to learn all of that. But then the Polygon stuff specifically, like this sort of thing, that's my own code. I just learned how to do it by all kinds of Googling and figuring things out on my own. So that comes from my own library here, SVG-CLJ, and the parametric stuff, for example, comes from here, parametric, and let's use a line as an example here. This line function returns a function that takes a parameter t and does a linear interpolation between the starting point and ending point. It's as simple as that. It just is a function that you give it a float value between 0 and 1, and it gives you a 2D coordinate point. And I learned the ideas behind that through various things like Pomax, Bezier curves, primer, so all sorts of different things, and just kind of figuring it out and piecing it together on my own. So like this, for example, this whole article shows kind of different approaches to building Bezier curves, linear interpolation, all kinds of math goodies like that. So I went through this a bit, tried different implementations, figured it all out one little bit at a time. Don't really have a concise answer. It's just, it was a lot of reading and studying and failing and trying again and that sort of thing. With SVG as well, what was the last site? Oh yeah, sorry if I'm going too quick here. So pomax.github.io/bezierinfo. This site is fantastic. There's a GitHub for it as well, pomax/bezierinfo-2, if anyone's interested. Phenomenal resource, really well done. Let me just see if I can go. And so when it comes to using SVG to render stuff into a browser or into the REPL like I showed you, you got to know a little bit of information. Resources are valuable. Thank you very much. Oh, of course, glad to help. Yeah, there's all kinds of great stuff out there. For what it's worth, I saw on Hacker News today, someone posted a link to this. I haven't fully read it yet, but this here, Curves and Surfaces, is an amazing interactive post with all kinds of really neat interactive elements explaining all kinds of cool stuff about Bezier curves and surfaces. So this is, I know a little bit of this already, but this is another resource and just another way to visualize and see how you can make 3D curves and surfaces. And this is another resource that I'm going to use to implement more features into my library, that kind of thing. So it's a lot of keeping your eyes open and just searching different things related to these, and hopefully you can learn enough math to try and implement things yourself. And they don't have to be perfect, right? You'll learn a lot of things as you go and fix it up. Anyway, this is another really cool site. Yeah, that's, let's see here. I find these sites really inspiring. I'm like slowly working my way to having tools and the ability to write this kind of stuff myself about mechanical engineering stuff, but that's a tangent for another day. In the meantime, there's some useful stuff over here. So I want to get back to this for a second and show a real example of an actual tool that's a little bit useful here. So let me figure out first of all what I did wrong. Excuse me. I have to do okay. Oh, what? Something went weird with my, there we go. That was strange. I don't want to see. Why is this not working? Oh, I'm being a little silly. Right. What is this website? Bezier game? This is a beautiful website. I don't know what's happening though, to be honest. Oh, I see. Oh, okay. So, Bezier game, skip the tutorial stages. Oh, okay. So it's all about how to, I see. That's a really cool site. Exercise for Bezier curves, very useful. Yeah, so I'm kind of doing curves programmatically here, right? I have mechanisms for importing, like I use Inkscape sometimes to draw stuff out, right? It's got a nice interface, and then I can save those SVGs, and then I can actually import elements from those SVGs and then use them in these contexts. So I have, it's not in this project, it's in another one, but I could, for example, save a font file to SVG and then load the glyphs and get the curve data and then use those curves for 3D modeling. So that's pretty cool if I do say so myself. Right, but here's an example of a surface generated with my code here. So you can make vases with it as an example. Let's do... Oh, here, this B vase is kind of a cooler one. Let me find the error that I've got here. Oh, it's right here. Simple enough. Let's actually tone this segment down. Hey, Bixie V, or Bixive. Sorry if I get your name wrong again, but thanks for the follow. I do appreciate that a lot. All right, let me show you this B vase, for example. I'm doing a relatively low segment count, so it won't look perfect, but here we have, so this is, see this, it's technically a really bad triangulation, but if I were just doing this to send it for 3D printing, I could make the argument that I don't care as long as it can render the mesh into a proper solid and then export it to an STL. The 3D printer doesn't really care if the mesh is kinda bad in terms of the triangulation. If it holds its shape and the printer can handle it, then we're good to go. That's not to say I'm not going to build better triangulation approaches later on, but for the sake of argument, I can, like as a starting point, this is pretty good. And you can see here, so the edge of this is approximated with a low number of segments, but it is technically what I did here. It's the same. Oh, I cleared it. Let's do this again. It's the same. I mapped. Where's that show 2D? This edge is supposed to be a smooth sine wave, so I would need a much higher resolution in the U direction, and then I could have a lower resolution in the V direction. So U being the parameter along this curve, and V being the parameter up along Z. But that's stuff for another day, or off stream. I don't have much time left. I'm gonna head to the washroom for a minute and think about what I want to do for the next, say, 20 to 30 minutes. I will be right back, and then I'll know exactly what I want to work on. Okay, so I don't have a ton of time to do this, but I'm gonna make a general curve saying here? This. Oh, maybe I already have all the tools I need to make this work the way I want it to. I'm gonna try to do an extrude curve of an open curve shape. So I'm gonna do, I'll extrude, first I'm gonna just extrude a line along Z and see if that generates a nice surface to look at. And then I'll try a Bezier curve. I feel like that's a cool thing to try. Okay, so let's do instead of just building a rectangle like I did here, what I'm gonna do is actually build a rectangle by means of extrude curve. I'm going to extrude it up 200, and the curve is going to be P/line from, well, I mean, we'll start at 0, 0, and then we'll go to 100, 100. Seems good. And the segment size is 10. Let's try that. See what it looks like. Okay, there we go. Really boring, but it is pretty much exactly what I was hoping for. So if you look, the line here has a clear endpoint at it. If I were to just guess, it looks like it's at 100, 100, and now this looks like it's at 100, 200, which is exactly what we hoped to see. So pretty great, gotta say. Alright, so let's refactor this to use the thread macro, because I find that a little more readable. So I'll do P line 0, 0, 100, 200. Okay. Then I'm going to run it through extrude curve 200 like this. Let's turn this down a little bit. Why don't we? And then I'm just going to run that through open surface 10, and then just get rid of this because it's wrong now. All right, let's by the way, if we change this to like 100, let's see if it works. It should. This should be a really, really tight mesh now. Yeah. Right, so that's the thing, right? This open surface is it's the discretization phase. Everything prior to this step, it's all still perfectly parametric. So it's like mathematically a continuous thing, but you have to, for reasonable rendering, you kind of do have to discretize it. And for near real time, for interactive feedback, you kind of want to keep it low if you want to render it out to a solid for printing or an animation that you don't care if it takes a while to compute. Then you can go with much higher resolutions, much higher segment counts, much smaller triangles, and you can get really, really fine mesh detail. There are way smarter ways to do it. Like, it's very naive to make everything super small. Like, especially if you know the surface is literally a flat surface, there's no point in meshing it like this. You could literally do it as two triangles. But I'm not going to worry about those things right now. I need to get the thing kind of working and then figure out where I need to optimize as I go. Because some of those optimization things are currently above my knowledge and skill level. Not forever, but currently. Right, so blah blah blah. I have a fun idea. I don't know if it'll work, but let's give it a shot. Let's do function offset, P/function offset like this. and then I want to offset it with p/sine wave. Let's do 2020. This should work. Ooh, it doesn't. Oh, I did it in the wrong spot. I have to do it before the extrude. Because I have to do it in the plane like this. This should work now. Should produce a result anyway. It might look weird. As in, not like anything apparently. It might actually be... Why is that? There we go. So that was kind of a cool example of how things can go wrong. So I had a sine wave mapped to it, to the surface. But my sampling rate was a multiple of the amplitude. So yeah, so it ended up like anytime I sampled the surface, it was at exactly the same peak or trough in the sine wave. So it looked like a flat surface, even though mathematically it is clearly not. So, you know, buyer beware or whatever it's called. I don't know what I'm talking about. Let's just do something like this. Let's make this 20 samples. There we go. So you can see the point is it is mapping something to something. So that's pretty cool. Let's do a Bezier curve though. Right, so we've got something like this. Is this gonna work? Ooh. What's the argument structure? Bezier, I think it's points, like a list. Oh yeah. I have to do this now. Not a big deal. All right, let's see what this looks like. I don't think it'll look good. Does it look like anything? Not really. So the obvious next extension to something like this is to do things like extrude along paths and to do surfaces from where it's like every surface is produced, or sorry, every edge of it is bounded by a Bezier curve. So you get a Bezier patch surface. There's and building from there. And there's all kinds of crazy stuff to do. I think the next obvious useful feature that I want to start working on is something like extruding a 2D sketch along a 3D curve to make things like weldments, to make things like smooth extrusion shapes, anything like that. So that I'm going to start to need to do 3D curves and make sure I've got good quick approximations for things like arc length, first and second derivatives of the curves, so getting the tangent vector at any point, getting the curvature, blah 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 blah. All kinds of stuff has to go into that so that extruding a shape along a curve has a sensible orientation at every step. These are all things I know I need to do. There's some things I don't know how to do it yet, so I'll have to figure it out as I go. But those seem like fun kind of next steps anyway. Before that though, I actually realized probably I'll do it tomorrow. I want to make a video and release like a YouTube video about some of the stuff I've done already for people who want to do 3D modeling with Clojure. There's some interest in those categories, so I think I should get working on that soon. Okay, so I'm gonna give myself a couple minutes yet to kind of play with this just a bit further, but I should get going soon. Okay. Oh my goodness, I just realized as well, thanks for the people who followed today. That actually put me over the 300 follower mark. So, you know, maybe it's small numbers in terms of Twitch and everything, but I'm really proud of that, really happy. So thanks everyone who follows this channel. That's super awesome. I'm so super stoked. I'm just glad people are interested in watching me casually code my way through things. That is very encouraging to me. Let's see what happens when I do this. Also, let's turn the sine wave off just so we get a pure Bezier here. Thanks for the stream. Oh, well, I'm glad you like it. It's very fun to do. Blah, blah, blah. It's very fun to do. What is happening here? Let me see. I feel like there's something wrong with this Bezier curve. Let me see what I can do here. Let's do show 2D. It's just a bad curve, really. So it is rendering the surface the way I'm asking it to. I've just written a bad Bezier. I've just written a set of bad Bezier points. Well, that's just my bad. Let's get rid of this. So this here, there we go. Now we've got something that actually looks like a surface. Okay. Right, so that's a thing. When you start extruding curves, right, a curve can be valid in a mathematical sense, but if it loops over itself, and then you try to extrude that, and then if you want to do something with that surface, you could have real problems. It might be non-manifold, right? Like, you probably want to, if you can, figure out if there's those self-intersection points, and if you want to be able to use it in a 3D context to make closed solids, you'll either have to disallow that or figure out a way to literally split the curve at that point and generate two independent curves. So visually it'll look the same, but mathematically it'll be two separate solids that you can then either bool together or bridge somehow, kind of create a continuity at those points. But I find myself yammering. Sorry about that, everyone. That sometimes happens on this stream. I just kind of talk. But there we go. That's a Bezier. It's pretty cool. Let's see what happens, or let's see what it looks like now if I do this. Weird and cool. I like it. It's ridiculous. Procedural generation of geometry is a lot of fun. I really like it. Oop. And I'm more and more proud of the work I've been doing, honestly, with this stuff. It's cooler and cooler to me every day. Okay, let's do this. Show 2D of this. So here's what I love, right? I'm using my SVG library, which just is not only, but in a lot of ways it's just algorithms on lists of points. And then I can render it out in 2D SVG, and I can use that exact same code to produce 3D, to produce stuff in a 3D environment. So my ultimate goals are to have both of these environments working with the same base code, so that I can quickly generate SVG technical drawings, right, with dimensions and top view, front view, side view for CAD and for manufacturing, and have nice 3D visuals that you could say throw up on your mobile, on a mobile app or something like that, so that people can see the high level 3D render of something and get technical details from the same source. That's kind of, you know, why I like using that's just one thing I like about how I've been proceeding with this, I guess is a fair way to say it. Is it all perfect? No, absolutely not, but I've got to say I'm pretty happy with myself. That's the truth of it. Ooh, that's fun. Oh, another thing that is fun to do with this is generative art, which is another sort of thought I've had for things I can use all this for. I mean, this project I'm working in is literally called a pottery project. So, like, you know, it's a creative sort of thing there. Yeah. Okay. I wonder. I'm just trying to think of something else cool that I could do. And that would be, well, what might it be? Okay, here's what's going through my head right now. I'm just thinking of quick ways to do a rough and ready extrude along a curve function. And what I'm thinking is, I realize, so the curves I have right now are pretty neat, but they are all planar curves. As in, this Bezier curve is a two-dimensional curve. You put in a t value and you get a 2D coordinate out of it. You get a coordinate that's x, y. What do I mean by that? If I do, let me def a. So if I run a 0.2, I get, this is a 2D coordinate. It is not a 3D coordinate. I mean, it is implicitly 3D if you take z to be 0. Or you can cast, like I could make a little function that makes y 0 or makes x 0, so then it'll kind of project onto a different plane. But it's planar. It has two dimensions of utility, I guess would be kind of a way to say it. I want to be able to extrude things along 3D curves, but I don't currently have a way to generate a 3D curve. And honestly, I do think 2D curves most of the time will be pretty much what I want. I also do realize that, actually, let me check if this is possible. Oh. Oh, okay, so I can actually generate 3D lines with these parametric curves. So maybe I'm wrong. Maybe I can generate 3D Bezier curves right away. Now that I am realizing this, let me try this. This is me thinking out loud, by the way. I'm off the rails in terms of planned work. I'm just experimenting now. Let's do 0, 0, 0, and let's do 100, 200, and we'll do -50 in the Z, and see if this works. Or if I broke some assumptions this way. Yeah, something broke. Right, so I do believe now, why is this breaking? Oh yeah, here's why. It's because, pardon me, where is it? It is up here. Okay, so this curve, right here you can see I am concatenating z times v. So what I actually need to do is have a condition where if the curve is known to be 3D, so if curve 0 emits vector with 3 dimensions, then z has to be z plus. Can you do that doesn't work. Okay. Okay. Basically what's happening here is curve u in some, like, in the planar case, the curve 2D emits an xy value, and you can concatenate the z value on there, no problem, easy. But if curve is a 3D curve, suddenly if I'm concatenating there, I actually have a 4-dimensional vector, which is nonsensical in the context of making a surface. So what I actually need to happen is this value to be added to the emitted z value, and that will extrude the surface along z the way I anticipate, or the way I was hoping it to be computed. So right, so how do I want to handle that? Let's okay, here we figure it out. Let's do curve 0. Okay, all I need to do is check if there's a z value here. So if what's the right approach? I think it's like this: f and args. No, what am I doing? Let's just whatever, make it a curve. So here we go. So the function, whoops. Function, so the return of this is just going to be function concat sorry, I have to do it this way. Function of t concat onto curve 0. It's very simple. It's just concat curve t I could do it as conj and then cast it to a vector. I wonder if that's actually faster, but it doesn't matter in this case. All right, here we go. So all I'm doing is let z be that. So if, so curve is if z, then curve is curve. Otherwise, curve is lift curve to 3D of curve, like this. Am I doing this right? I'll find out in just a minute. Alright, so now, here, we know that I can do a little let inside here. We can let point be curve at u. And then here, what we do is point plus this point, which is going to be like this. Okay, so we just do this. Let this point, you know what, let's not even do it that way. Let's just do, okay, so we've got SVG utils is v plus. We're going to add these vectors together. You just add curve u and this point 0, 0 z times v to get your z height adjustment. Okay, let's see if this does what I want it to. If it works, this will be the last thing I have time to work on for the day. Where am I at here? Okay. Let's see if that was the right thing to do. Seems like the answer is no, it was not the right thing to do. Alright, well, let's try this. Let's build an extruded curve. Instead of this, open surface, let's do this. Okay, so we've got rectangle surface is a function at this point. I mean, it is emitting 3D points. Okay, so what did I do wrong now? I kind of thought this would work at this point. I wonder why that's not working. Well, let's have a look at, whoops. Let's try check validity here. I mean, it says it's valid. It has one element. I'm just wondering why I can't see it. Okay. I feel like I'm missing something obvious here. Got 3D points. I do need those. Oh, look at this. The first point is incorrect, but every other point seems to be correct. So, why would that be? Let me see. Okay. Wait a minute, why is it... Okay, so I did something wrong. That's why. Let me see. Let me just sanity check this. Do we get a working surface in the 2D case? It would appear no. So I broke something. Okay. Let me just simplify this. Let me not put in checks into the function. Let's just make two functions and then figure it out later. Okay, so we've got extrude curve 2D is what I want to make this. Sorry, let's make this one 3D. Okay, so let's just assume that the curve is what it is. Okay, so we've got curve u plus this vector. There we go. So extrude curve 3D should be that. No checks, no nothing. Let's go try to make this work. 0, 0, 0, that whole thing. Extrude curve 3D. Let's try this now. If this doesn't work, there we go. Okay. Right, so it's just a matter of me failing a check or something like that. Okay, there we go. So we successfully have 3D curves being extruded in the Z direction to create surfaces that can be offset and whatever. So that's good. Here, okay, well, you know what? That's a really good start. Let me just finish this up by actually making sure I have an extrude curve 2D and then go from there. I feel like this is, I went wrong somewhere with this. I must have. Excuse me. Yeah. Right, so in the 2D case, it's just gonna be I mean, I may as well do this, right? Concat and that'll work. So let me just double check that. Went too far. Here we go. Alright, so this line, we're going to make it two-dimensional again. And we're going to extrude curve 2D. There we go. Right, so now if we do 3D, we should see, yes, good. Okay, well, that is a really good set of work that I did. I feel pretty good about today. I pushed some new features to my SVG library. I've got things working on here. I've got the next steps in my mind and ready to go for more advanced curve extrusions. We're cooking. I made it over 300 followers. That feels fantastic. Thank you everyone who's tuned in and helping with all of that stuff. Love it. I've got a YouTube video ready to make soon. I'm feeling good about things. So thanks everyone for tuning in. Thanks for the support. Thanks for the kind words. Thanks for your time. And I'll be back streaming if you're interested on Thursday and Friday again. So that's usually my schedule with a bit of flexibility for my real life stuff. I do Monday, Tuesday, Thursday, Friday. So it's about 4 times a week. Anywhere from 1.5 to 3 hours that's usually my stream duration. that's what I've got going on. And I do CAD stuff. I do programming with Clojure. I do apps. Well, apps is maybe the wrong word. I do like web pages with visualizations and SVG and stuff like that. So, and I just like over time like to learn and try to get better at programming. So that's all the kind of stuff that ends up on this stream. That's all I gotta say. I gotta get going. Thanks everyone for tuning in once again. I will be back on Thursday. Have a good one, everyone. Have a good one.